Hello students, welcome to a new lesson in physics. Students, I have a question for you. Have you ever tried pushing a door from the hinge side and realized it just doesn't work? But when you push from the handle, it swings open effortlessly. Why does this happen? The secret of this lies in something called as the turning effect of force. Let's dive into understand turning effect and find the answer that why door handles are placed away from the hinges. Hello everyone, this is Sarvesh here and I welcome you all to this new chapter of IGCSE Physics. Today, we are going to explore a fundamental concept that governs everything from opening doors using scissors, swinging on seesaw, etc. And that's called as the turning effect of force. By the end of this video, you will not only understand why some objects rotate more easily than others, but also learn how to calculate this turning effect. Note that the turning effect is also called as moment of force. Let's get started. Now, before we understand turning effects, let's classify motion in two main types, that is linear motion and circular motion. Linear motion, as the name suggests, is a motion in straight line. For example, a car moving on straight road. We need net unbalanced force to bring body in linear motion. Whereas circular motion is motion around a fixed point or axis of rotation. For example, ceiling fan, Ferris wheel, etc. As we need force for bringing body in linear motion, we need moment of force to bring body in circular motion. Now that we know the two main types of motion, let's focus on circular motion. The key thing to note here is that whenever object is in circular motion, it always moves around a fixed point, and that fixed point is called as pivot. Now here, the turning effect comes into play. We are now going to understand in detail what is meant by pivot. We will now try to understand what is pivot. Students, note that every object that rotates, it does so around a special point called as the pivot. The pivot is the fixed point around which rotations occur. For example, in seesaw, the central support along which the plank swings is the pivot. In case of fan, the center point where the blades are connected is the pivot. In case of scissors, the pivot is the joint where the two blades meet each other. Similarly, when we talk about the planetary motion, the planets, they rotate around sun, so sun acts as pivot for planetary motion. Knowing the position of the pivot is essential in calculations of turning effect, as all the distances in calculations are measured from the fixed point that is called as pivot. Now that we understood what is a pivot, let's try to understand some more examples related to turning effect. Turning effect are everywhere in our daily life. Let's look at some examples related to it. When you open the door, it moves in arc, which is an example of circular motion or turning effect. While opening the door, the further you push from the hinges, the easier it is to open the door. The efforts required are lesser. While using a wrench to loose or tight a bolt, a longer wrench makes it easier to rotate a bolt. Can you think why or what would be the pivot in this case? Yes, you're right. The bolt itself is a pivot here, as wrench rotates around the bolt. In case of scissors, the force applied at the handle creates rotations around the pivot and helps us to cut through the objects easily. Like this, there are many examples in our day-to-day life which deals with the turning effect of force. For example, cranes, for example, the steering wheels, etc. Now that we see turning effect is everywhere around it, let's define it. The turning effect of force or moment of force is defined as the measure of how much a force causes an object to rotate about the pivot. Its mathematical formula is force multiplied by perpendicular distance from the pivot, and the SI unit is Newton meter. In case the distance is measured in centimeters, you can also use the unit Newton centimeter. Let us understand this using a numerical problem. Consider a rod of 5 meter length. It is fixed at one end and applied with force of 20 Newton at distance 5 meter from the fixed point. The moment of this force can be calculated using formula force multiplied by perpendicular distance, that is 20 into 5, 100 Newton meter. Note that the distance taken here has to be always perpendicular. It means the angle between the line of action of force and the line measuring distance must have 90 degrees angle in them. For example, consider a ladder resting against a wall, experiencing force from the wall. The other end of the ladder acts as the pivot, the end of the ladder which is in contact with the ground. It is pivot for us. The perpendicular distance will be vertical distance between the pivot and the line of action of force from the wall. We will now talk about the two key factors, those change the turning effect of force. From the formula, we understand turning effect depends on force and the distance from the pivot. Turning effect is directly proportional to both of these quantities. That means, more the force, greater the turning effect, and greater the distance from pivot, greater the turning effect. So, turning effect is directly proportional to force and the perpendicular distance away from the pivot. In order to apply less efforts and produce greater turning effect, we have to apply force at relatively longer distance from the pivot. Now that will give you an answer to my first question in the beginning of the chapter, that why it is easy to open the door when force is applied away from the hinges. Now that's the reason why the handles or the doorknobs are deliberately kept at the longer distance from the hinges. Hinges act as a pivot for the door, and if the door handle is kept away from the hinges, it makes it easier for us to open the door even by applying lesser amount of force. In another example, you can see that when we use a shorter stick to move heavy stone, it moves slowly, but when we use a longer stick, the same stone moves faster, meaning we are able to produce greater turning effect by applying lesser force since we have taken longer stick. As the distance from the pivot increases, the efforts decrease, or with less force, you can produce more turning effect. And that's the secret behind why doors, wrenches, and even seesaws work the way they do. In our next lesson, we will explore the principle of moments and how balancing forces keep objects in equilibrium. Before we wrap, you know it's time for Scratch the Brain segment, in which I will give you a real-world problem about today's topic and you are supposed to brainstorm on it. So today's question is, why do you think trucks or buses have larger steering wheels than the cars? What is the effect of the size of steering wheels in driving these vehicles? Scratch your brain on that, and I will see you in the next video. Until then, keep questioning, keep learning. Thank you.